Hi, this is Dr. S and welcome to my series on reaction rates for Year 12 Chemistry. Now in this video we'll look at what a reaction rate is and how we can represent it on graphs, and in future videos we'll look at what can affect reaction rates and how we measure them. So firstly, what do we mean by a reaction rate? Well, we mean the speed at which a reaction happens. So there could be fast reactions like explosions or slow reactions like the rusting of iron. But both of them we could quantify using this equation, which is the change in concentration over time. Now if it's change in concentration over time, then the units of change in concentration are moles per decimeter cubed. And the units of time are normally seconds. So that gives us a unit for rate of moles per decimeter cubed per second. Now you might well find that there are other ways, as you go through this topic, other ways of measuring rates, and you might find that there's some things like change in volume of gas, in which case you could see a rate as centimeters cubed per second, or there might be ways of measuring the mass lost in a reaction, in which case you might find grams per second, but both of these two can be converted to moles per decimeter cubed per second if you so wish. So it is this unit that we will use as we move forward. Okay, so how would we see that? So we might see it on a graph like this, where we have time on the bottom and concentration up the side. So that would be in moles per decimeter cubed, and this would be in seconds. And let's imagine that we had a reaction in which something was being used up. So the concentration would decrease as time went on, as the reactant was used up, and you might end up with a curve like that. So you should be able to see that as the reaction goes on, time progresses, the concentration of the reactant decreases. You should also be able to see that this is not a straight line. It's a curved line, suggesting that it is used up, the reactant is used up faster at the beginning of the reaction than it is at the end. And what we might see is that as we go further on and further on, then this will tend towards zero, and eventually all the reactant will be used up. This is not always the case. There are other examples as we go through the A-level course where not all of the reagent is used up, but you can see in this case it is. And the reaction rate is getting slower as we progress because the steepness of the curve is getting shallower. What you can also imagine is then a similar graph for if we were producing a product. Again, time in seconds, concentration in moles per decimeter cubed, and this time we're measuring a product. So the curve would go up like that. Again, we produce the product faster at the beginning, and then the speed at which we produce the product levels off, and eventually you get to a point where it plateaus, where it goes flat. That is the point where the reaction stops. So I would say about here the reaction has stopped and there is no more product produced. Okay, so you should be able to see how we can relate reaction rate to a graph. We can see how the reaction rate will change as time progresses in a reaction, and this should link to what you already know about rates. Okay, in my next videos we'll look at something called the collision theory, which starts to explain why the shape of the graph changes as you go through time. Okay, I'll see you then.